that's new, but I'm sure you're doing great. But now we're going to get into the meat of what we're going to talk about for the next 2 weeks, which is right triangle trigonometry. But before we start on it, we do need to go over some vocabulary. So first we have this little symbol here, and the name of this symbol is theta. And for now, we just need to know that theta means that's the angle that we are using as our reference angle. So it's called our reference angle, or the angle we are going to start from. Then, when in a right triangle, we're always going to have a side that's called the opposite side. So I'm going to let me draw a right triangle here. Wherever I put theta, right, that's going to be my reference angle, so that's where I'm going to start from. If we're looking at the opposite side is always the side that is across from theta. So opposite is across from theta, or whatever angle we're using, it's the one that's across from it. And just a note, the 90-degree angle will never be our theta. It'll always be one of the other two angles. So opposite is across. Adjacent means next to. But if I look at this side and this side are both next to theta. So it's probably more helpful if first we go back to hypotenuse, which, hey, we just talked about hypotenuse. We know what that is. We know that hypotenuse is across from the right angle. So it's always the longest side. It's always across from the 90-degree angle, which means the adjacent side is the final side left, right? We've already got the opposite. We've got the hypotenuse. There's only one side left. It is the other side. Or we can say, since adjacent means next to, it is the side that is next to theta that is not the hypotenuse. So again, this right here would be the adjacent, or we abbreviate it ADJ. The hypotenuse is always across from 90, right? Which is also adjacent to theta, but we give it a special name because it is the longest side. And then our other side, or our opposite side, is always the one that is across from theta. So, some examples. Label the sides of a triangle according to theta. All right, well, here's theta right here, down at M. So if theta is M, which side is opposite? That's right, our opposite side from here would be CD. That is opposite. Okay, well, if theta is there, and it doesn't matter where theta is, which side's our hypotenuse? That's right. Our hypotenuse will be side MD. And we know that's the hypotenuse because it's across from the right angle. Which means we only have one side left, right? And what do we call that final side? We call that final side the adjacent. So the ADJ is always right next to theta. Okay, so we can do that again. Now my theta has moved, right? It's now up here, so I have to be careful of where I'm starting from. If my theta is up there, which side is opposite? That's right, the opposite side will be SF because it is across from theta. We know the hypotenuse is always across from the right angle, which means our final side has to be the adjacent side. So I know that this side right here, right next to the theta, is the adjacent side. So it's a lot of vocabulary. If these words are new to you, you're going to be okay. Just know that we're going to end up using these words a lot. No fear, it's not tough. Sine is always going to be opposite divided by hypotenuse. Cosine is going to be the ratio of the adjacent divided by hypotenuse. And tangent will be the opposite divided by the adjacent. Now that might seem like a lot to memorize, but we're going to use sohcahtoa. Sohcahtoa, sohcahtoa, sohcahtoa. What? What is Mr. Dresser talking about? Well, sohcahtoa, sohcahtoa, you want to know how to spell this, it's really important, is a way for us to memorize the different ratios. So S stands for sine, and sine is always equal to the opposite divided by the hypotenuse. Or S equals O over H. So sine equals opposite over hypotenuse. And then we have C, or ka, which is going to represent cosine. And cosine is going to be the ratio of the adjacent side divided by the hypotenuse. Or C equals A over H. So ka, right? Ka. Cosine is adjacent over hypotenuse. And then finally, our last trig ratio is going to be tangent. And tangent will be opposite divided by adjacent. Or T equals O over A. So toa, tangent equals opposite over adjacent. So when we put that all together, sohcahtoa. Or you can think about it as like, here's a bathtub full of water, you've had a long day, you sit down in your chair, and you put your toe in the water, and you soak your toe. No, okay, all right. Sohcahtoa, 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 sohcahtoa. So here's how we can use sohcahtoa. If you're asked to find a ratio, and you're asked to find sine of A, well, sine, that's going to be so. So I know that that's going to be S equals O over H. So I'm going to go find where angle A is. That's going to be my theta, right here. And I need to label that the side across from theta is my opposite. The side that's across from the 90 degrees is my hypotenuse. And the last side remaining is my adjacent. And I know that sine is the opposite over hypotenuse. So my sine is going to be opposite, which is 5, over the hypotenuse, which is 13. So the sine of angle A is just 5 over 13, because that was the opposite side over the hypotenuse. When we go to do cosine, I know that that's ka, or C equals A over H. And so I'm going to go to my adjacent side, which is 12, divided by my hypotenuse, which is 13. And the ratio of the adjacent over hypotenuse would be 12 over 13. And then tangent, I know that's going to be toa. So I go find my opposite side, which was 5, divided by the adjacent side, which is 12. And I now have a ratio for the tangent that'll be 5 over 12. At this point, you don't have to worry about what we're going to use this for. That's going to come in the next couple days. But for today, you just want to be able to memorize sohcahtoa. Okay, so now we're going to do the same thing, but we're going to do it with angle B. So I need to make sure that I know we're finding the sine of B, cosine B, tangent B, which means B is going to be our theta, or our reference angle. So I'm going to go to angle B, which is up here, and I'm going to label the side across from it as the opposite, the side across from the right angle as the hypotenuse, and the last side as the adjacent, ADJ. All right, so when we go to find sine, we know that it's going to be so, right? So sine equals opposite divided by hypotenuse. So my sine of B is the opposite, which is 12, divided by the hypotenuse of 13. My cosine is going to be ka, All right, cosine is adjacent over hypotenuse. So that's going to be 5 over 13. And then tangent is my TOA, or my tangent equals opposite divided by the adjacent. So opposite is 12 divided by the adjacent of 5. So 12 over 5. All right, let's have you do most of this one. First thing I'm going to do is label my opposite, hypotenuse, and adjacent. And we know that the angle that our theta is going to be is angle T. So I'm going to go find angle T. This side right here is called the opposite. The side across from the right angle is our hypotenuse. And the leftover side is called the adjacent. Very nice. So now when we go to find the sine of t will be, that's right, the sine is going to be the opposite over hypotenuse. So that's going to be 7 over 25. Okay, go ahead and find the cosine of t. Great job again. All right, the cosine is going to be the adjacent over hypotenuse. So that's 24 over 25. And finally, please find the tangent of t. You did it again! Great job. Tangent is going to be our opposite over adjacent, so 7 over 24. All right.
That was easy.
Yeah, that's what I thought. Okay, so great job. Sohcahtoa, sohcahtoa, sohcahtoa. Memorize that. Make sure you spell it right. We know that SOH means sine equals opposite over hypotenuse. We know that CAH means cosine equals adjacent over hypotenuse. And then TOA is tangent equals opposite over adjacent. And we are now equipped, as my friend Patrick would say, we are now equipped to hit that triangle with a little sohcahtoa. See you tomorrow.